We can also construct confidence intervals around proportions. You might notice this especially in an election season. It might be reported that candidate A is expected to receive, say, 52% of the vote plus or minus some margin of error. This percentage is based on asking a small sample who they will vote for, as opposed to asking everyone in the population who they will vote for, and then using statistics the pollsters generalize from a sample to the population. And so for this example, we're going to use a problem from your textbook. And this item up here states, a local school district wants to survey parental attitudes towards the proposed elimination of after-school sports as a cost-cutting move. Rather than send a questionnaire home with the students, the school committee decides to conduct a phone survey. Out of 120 parents questioned, 74 supported the plan to cut the sports program. Find the standard error of the proportion and the 95% and 99% confidence intervals for the population proportion. The first thing we will need to do is look at the formulas and see what information we're going to need. So we're going to use these set of formulas on the right to calculate the standard error of the proportion and the confidence intervals for proportions. And proportion is represented by P in these formulas. In the standard error of the proportion, what is required is the n and the proportion itself. We don't even actually have the proportion yet, however. We know that 74 people supported cutting the sports program out of 120, so we can do some division very quickly to find the proportion. So I'm going to put it equals, and 74 are the number of people who supported the cuts out of 120, which is the total number of the study. And that gives us a proportion of 0.62. And so another way that we might receive information is 62% of the group supported cuts to the sports program. And if we get a percent as our data, then we can convert that to a proportion by dividing the percent by 100. But we didn't have to do that this time because we were just given some raw numbers and we were able to find the proportion that way. The next step, similar to confidence intervals for means, is to calculate a standard error. So we're going to find the standard error of the proportion, which is equal to the square root of the proportion times 1 minus the proportion over the n of the study. Okay, so we're going to type this in right over here, and we don't know the n of the study yet, or we do, it's up here. We just need to add it, 120. So I'm going to start a very convoluted formula that's going to include a lot of parentheses, so bear with me. I'm going to put an equal sign and square root because that's the first part of the formula. I'm going to start a parenthesis for the grand terms. So this parenthesis is going to cover everything because we're going to find the square root of all of these things. But I also have a numerator, and that's also going to include its own parenthesis. So I'm going to put that there, another one. I'm going to insert P, and then I'm going to multiply P by, and I need another parenthesis for this inner term, 1 minus the proportion. I have to close that subtraction term, and then I have to close the numerator. I'm going to then divide the numerator by 120, and I have to close the grand parenthesis, and that gives us a standard error of the proportion of 0.04. That's a lot of parentheses. If that is too many parentheses for you, you can break down the steps one at a time to find the standard error of the proportion. So let's do that. We can take the first term, P times 1 minus P. We can easily do a formula for that, equals the proportion times 1 minus the proportion. Okay, that gives us 0.24. So we can take 0.24 and divide it by n. So now we have 0.00, but that actually goes off to some decimals that we're not seeing. And then we can just take the square root of that. And this time I'm going to use this square root of this number. Okay, and that gives us our standard error of the proportion just as easily. Well, not just as easily, I don't know, it just depends. For some of you, using parentheses might be easier. Others of you might want to spread it out like this. It's totally up to you. Either way that you do it, we now have our standard error of the proportion of 0.04. And the last step is to determine our confidence interval. We have the standard error of the proportion, so we can fill that into our formula. Calculating confidence intervals for proportion uses the z-distribution instead of the t-distribution. And as you saw in your book, for a 95% confidence level, a z equals 1.96. And for a 99% confidence interval, z equals 2.58. So actually this formula that you see here is for the 95% confidence interval. So we're going to use 1.96 when we're doing 95% and 2.58 when we're doing 99%. So let's just do it, shall we? Okay, we're going to start with the low end, and I'm going to plug in the information. So the confidence interval is going to equal the proportion, and the low end we're going to subtract, and we're going to multiply 1.96 times the standard error of the proportion, close it, and that will give us a lower end of 0.53. Okay, let's do the upper end for the 95th confidence interval. So we're going to do equals, we're going to put the proportion, and this time we're going to say plus 1.96 times standard error of the proportion, and we end up with 0.70. So our range, the 95th confidence interval range, has a low of 0.53 and a high of 0.7. So let's interpret that. This means that we can be 95% confident that the population proportion is between 0.53 and 0.70, or somewhere between 53% and 70% of the population support the plan to cut the sports program. For the 99% confidence interval, you do the same thing utilizing z for the 99% confidence. So our lower limit is equal to our proportion minus 2.58 times the standard error. So let's plug that in. Equals proportion. We're going to go with minus for the lower limit. This time 2.58 times standard error of the proportion. And we end up with 0.50 for a lower limit. Let's do our upper limit. Equals the proportion, this time plus 2.58 times standard error of the proportion. And that gives us an upper limit of the 99% confidence interval of 0.73. So we can be 99% confident that the population proportion that supports cutting the sports program is somewhere between 50% and 73%. Just as with confidence intervals, that means the larger the confidence, the larger the interval. So for the 99% confidence interval, we can expect our range between these numbers to be larger, and that tells us that we've done our calculations correctly. I hope that these 2 videos on finding confidence intervals helps you as you complete the practice problems at the end of the chapter. There is a learning curve with these calculations, but once you get the basic concept, they begin to be incredibly easy. Until you have this process down pat, come see me on the discussion board and ask questions.